So if you haven't figured it out yet, I am Jeremy Clark, and I have a website, www.jeremybytes.com, B-Y-T-E-S. And if you go out to that location right now, you will find these slides. You'll find the code samples that I'm talking about. You'll also find a PDF walkthrough that takes you through all of the cool stuff I'm going to show you today. In addition, you'll find a link to a Pluralsight course. I'm a Pluralsight author, if you're not familiar with it, really cool online training. And that actually has about 3.5 hours of material, so obviously stuff I don't have time to tell you today. And if you're interested in learning more about Pluralsight, I do have some free trial cards, so come hit me up after the session. I'll be glad to hand you one. Is that enough about me? That's enough about me. Because I want to talk about design patterns. Now, pretty much everything that I talk about are things that were difficult for me to learn personally, but I found extremely valuable as a developer. And design patterns falls into that category. Because a lot of times we think of design patterns as this is something that the architects need. So our architects care about these, but me as an average programmer, why do I care? What we'll see is that they're useful to us in our day-to-day programming, and in fact, we already use design patterns, even if we don't realize it. So we're going to look at that today, and we'll see how they're awesome. Does that sound good? Yes. Okay, I got one yes from the front row. We will go with that. Now we need to start out with what a definition is for design patterns. And this is a definition that we get from Christopher Alexander. So, Christopher says, each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use the solution 1,000,000 times over without ever doing it the same way twice. That's interesting, and everywhere you look at design patterns, you'll see this definition crop up. This has become the definition of design patterns. Christopher Alexander was not talking about software. He was talking about architecture, like real architecture with buildings and bridges and that sort of thing. But the definition has fit so well that we've adopted it into our environment. Now, kind of the people we can credit for making design patterns prevalent in our industry is really these guys here, which are known as the Gang of Four. Now, I think the reason why we call them the Gang of Four is no one's quite sure how to pronounce this. So I apologize, John, I will not try to pronounce your name. But this is a book, Design Patterns, Elements of Reusable Object-Oriented Architecture, and this came out back in the dark ages of 1994. 1994. What is that in computer years? Right? That's like 300 years in computer years. So the first thing we might ask ourselves is this still relevant? And I'm going to show you today, yes, it is. And in fact, I have a copy of this book, which was published in 2008, so even my copy is kind of old, and that's the 36th printing of the book. And it's still in print. Can you think of any technical book that makes it that far? And that's because it is very important to us. Now, I'm going to give you a couple warnings about this book in just a second, but let me tell you a little bit more about the contents first. So, when we're talking about design patterns, the Gang of Four came up with this idea that, well, there's kind of 4 elements that we talk about when we're describing design patterns. Now, this book is just the beginning of kind of the exploration into patterns and how they work and what we can use. And so they describe 23 patterns, but that's not the only source. There's pattern catalogs everywhere. We have new patterns coming up all the time. And so this is something that keeps going and going in our environment. But when we're talking about the patterns, we do end up with kind of 4 parts to our description. The first is the pattern name. Now, hopefully this is something that describes, either the problem that we're trying to solve or the solution, because this is what we're going to use in our everyday vocabulary. So we want this to really kind of reflect what we're talking about. Now, the Gang of Four did have it easy because they were the first ones. So they got to pick things like bridge. That's a nice name for a pattern. Now, today when we create new patterns, we usually have to give them longer names so that we're unambiguous. So we get patterns today like MVVM, the model view view model pattern. So a lot of times we end up with a lot longer names these days. So the pattern name, again, this is what we can use in everyday speech. Now, the next part of the pattern is the problem that we're trying to solve. And again, this is a problem that occurs over and over again in our environment, and we'll look at some examples of this in just a minute. And then after we describe the problem, we describe the solution. Now, as a reminder, this is just the core of the solution. Design patterns are not about a specific implementation. They're about a concept of big parts and how they fit together. And that's good, because that means we're free to implement them whichever way works best for our particular problem. Now, we do have some built-in solutions, especially since, again, we're over 20 years after the Gang of Four. So some of these patterns are actually in our languages now, which is really awesome, because that makes it easier for me. So again, this is the core of the solution, and there are standard implementations out there, but we're free to make up our own if none of those fit. Now, the fourth part, this is the thing that people don't like to talk about when they're talking about patterns, and that's the consequences. Because when people talk about a pattern, they say, well, you know what, I used a facade pattern here, and it was really awesome. It does all these cool things. Let me show you why it's the perfect pattern to use all the time. And they forget that we don't get benefits without consequences. So just like every tool in our toolbox, we have to weigh the pros and cons. Are we getting the benefits? Are we willing to deal with the consequences? If so, hey, let's go ahead and use it. So we're going to be mentioning a few consequences as we go. But again, this is something that a lot of people leave off. They'll say, let me tell you how awesome the MVVM design pattern is, and here's all the parts, and here's how it fits together, and here's how it does loose coupling, and here's why it's awesome. But they forget to tell you, oh, well, you know what, this adds complexity, and this turns some compile time errors into runtime errors. Again, if those are things we're willing to deal with, we definitely want to use it, but we need to be aware of them. So this is the basic structure that we have when we're talking about design patterns. Now, like I said, the Gang of Four described 23 patterns, and here they are. And again, they got to pick some really easy ones, like adapter and bridge, and builder and observer and state, because they were basically creating a new vocabulary at the time. Now again, design patterns are being created as we come across problems that we run across over and over, and we come up with good solutions for those. And so usually the things that we talk about now, we have to give more complex names to, because the easy ones are already taken. So again, the Gang of Four book, excellent reference. And I love books. That's how I learn. That's why I always give book references when I'm doing my presentations. But for the Gang of Four book, I am going to tell you 100% absolutely do not read this book yet. So the problem is the Gang of Four book is extremely academic. So like I said, my version is from 2008, and I got it to put on my shelf because it makes you look like a competent developer, right? This is one of the books you have to have on your shelf. Now, I tried to read this book 3 times and failed miserably because I wasn't ready for it yet in my career. So it is an important book, and I would recommend that you read it eventually, but it is not a good place to start because, again, it's kind of way, way up here. So for those of you who are new to design patterns, where do you start? I recommend this book, Head First Design Patterns. Now, if you're not familiar with the Head First series, the whole goal of this series is to stuff information into your head in a way that you can remember it. And so, very friendly examples. And in fact, this particular book covers 12 of those 23 Gang of Four design patterns. And it starts out with exactly the same definitions that are in the Gang of Four book. So it's not like it's making up something new, it's just describing the things that the Gang of Four did in a much more approachable way. Now, I'm primarily in the .NET world, and the examples that I show you today are going to be in C#. Don't let that scare you if you're not, because again, design patterns are really conceptual in nature, and the patterns we're looking at really apply to pretty much any OO programming language. And there are patterns for functional languages as well. So again, it's good to understand the concepts of what patterns are and why they're good. So in our case, I was talking about language, right? So this particular book actually has examples in Java. But again, if you kind of understand any curly brace language, it's pretty easy to follow along. And in fact, if you go out online, you will find some people that have translated the examples into other languages. So it's a really good place to start. Now, the Gang of 4 book, that's small talk in C++. Because again, those were our primary OO languages that we had back in 1994. So again, it's not really difficult to understand, kind of like, okay, well, we're dealing with object-oriented programming, and we're seeing how big pieces fit together and how communication works. So head-first design patterns, excellent, excellent place to start. So if you're brand new, that's where I would go. Are you guys convinced yet? No? Yeah, is there a question? So the question is it only for OO programming? Now, design patterns in general are not, but the particular Gang of 4 patterns, those really are geared towards OO programming. But there are other functional patterns, and I guess there's procedural patterns as well. I haven't really looked into those. But, again, I want you to get the idea that design patterns are important. And you're probably sitting there saying, well, why should I care about patterns? Right? I've shown you the book. I've shown you the list. I've told you it's really hard to read the Gang of 4 book. That's really inspirational, isn't it? Well, let's talk about why these are important in our environment. First of all, design patterns are well-described solutions. There are people who are way smarter than me who have been thinking about these problems for a long time. They have come up with solutions. I want to steal those solutions rather than having to come up with them myself. So design patterns are well-described solutions. So this is an excellent place for us to start. Next, it gives us a shared vocabulary. Now, as developers, we want to have a secret language. Lawyers have secret language, doctors have a secret language, even accountants have a secret language, right? Well, design patterns are part of the secret language of developers. So I can come up to you and say, hey, you know what, I'm using an observer in this particular instance. And you will know exactly what I'm talking about, and the guy in HR won't. That's good stuff. Actually, it's more important that it helps us communicate with each other. Now, as part of that, it also gives us a very concise language. Because I could tell you, well, I have an object that publishes an event, and when that event fires, I've got everybody else that gets notified of that. Or I could say, I'm using an observer. Which one's faster to say? Now, if we all understand design patterns and what they are, we can talk about the observer. Now, this has another side effect. It's not just concise, it actually allows us to think in design mode longer. Because when I say observer, I'm not talking about a particular implementation. I'm not saying I have a class that fires an event. I'm saying, well, we just have these objects that are related to each other somehow. It's a publish-subscribe relationship. So we can really stay in design mode longer. And I really like that because I'm a whiteboard person. And I was lucky because my manager at the corporate job I worked for many, many years understood that. And so when I was kind of leaning back in my chair, I had my feet up on my desk, and I was going like this, she knew I was working. So I was staring at the whiteboard trying to figure out how to fit the pieces together. So I really like the idea of, I don't do heavy design up front, but I like to know how are my pieces going to fit together. So this lets me think in design rather than in implementation. And then the last thing is if we start using these as part of our everyday language, it's going to encourage other developers to learn about them. Because if you're having a hallway conversation with somebody, and you come across and you say, well, you know what, I was using the adapter pattern here, and it was the perfect fit for the problem that I had. Well, if there's another developer who overhears that, they might say, maybe I should learn about the adapter pattern. Maybe that's something that I need. And so that's how we can use this to spread our vocabulary to other developers. So now does it seem like we should care about these? Is anybody still there? Yeah, I know. It's late, isn't it? Yeah, I know. 3 o'clock in the afternoon is incredibly late. So let's talk about some patterns that you already use. Now, the reason I like to talk about this is because I had a developer who sat next to me, again, for many years, and he had about 10 years of seniority on me and experience. He'd been a developer longer than I had. And one day, he just pops up over the wall, and he's like really excited. He says, I've been using the Facade pattern, and I didn't even know it. And I was like, that's really cool, but that's also kind of a problem. Because if we know about these things in advance, now we can start using them intentionally rather than accidentally. And that's really what I want to focus on. So let's think about some patterns that we already use today. And I'm going to start with the observer pattern. Now remember how I said the gang of 4 is a little difficult to understand? Well, here's the gang of 4 description of the observer pattern. Define a one-to-many dependency between objects so that when one object changes state, all of its dependents are notified and updated automatically. Wah, 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 wah. Right? Again, not a good place to start. But when we narrow this down, all we're talking about here is a publish-subscribe relationship. And we all understand what publish-subscribe relationships are. Why? Because we're on Twitter, right? So if you'd like to follow me on Twitter, I'm @JeremyBytes. Feel free to do that. Now, when I'm talking about Twitter, I'm specifically talking about the follow functionality. So in that situation, we now have the subject and the observer. So if you follow me, I become the subject. And every time I change state, which means I send out a new tweet, everybody who is observing me gets notified of that. That's pretty straightforward, isn't it? Okay, do you guys want to look at code? I'm at Code Camp. I like code. Slides, not so much. Okay, but I have a poll question first. Who here has ever hooked up an event handler? Anyone? Wow, not many people. Almost everybody, right? It's something we do every day. Well, it turns out that if you've hooked up an event handler, you have used the observer pattern. So I'm going to go ahead and pop open our project. This is an awesome project. And again, you can download this code off of the internet from my website. And I'll go ahead and zoom in so we can look at the projects here. So I basically have one project for each of the patterns that we're going to talk about today. Plus there's a couple bonus ones if you want to explore a little further. So we're going to start with the observer pattern. And I am going to amaze you with my programming skills. You guys ready? I'm going to run this application. Ta-da! Ta-da! It's a form with a button on it. There's also a couple text blocks that you can't see there. And right now, the button's not hooked up to anything. And so what we're going to do is we're just going to do that in code so that we can see how the observer pattern works. So I'm just going to go to the code behind here. And inside our constructor, we'll go ahead and hook up the event handler. Now it's called click me button. So I'm going to say click me button dot click. And I'm going to say plus equals. And Visual Studio says, it looks like you're going to create an event handler. Do you want some help? If so, press tab. Woohoo! Do you want to call it this? No, let's go ahead and call this the observer 1 and press tab again. And it just creates all this for me. I love this. Why? Because I am a lazy developer. Are there any lazy developers in the room? Wow.
Is there any other kind?
Real lazy developers don't raise their hands, so I'm actually looking at the rest of you. So, but you know, I'm not happy with just one observer. Let's go ahead and hook up 3 of these guys. Okay, so we'll make an observer 2 and an observer 3. And these guys are just all going to be connected to that same event, which is the click event of our button. So again, we'll have observer 2 and observer 3. Okay, this is where I'm really going to wow you with my programming skills. Because up here in our first event handler, I'm going to say text block 1.text equals hello from observer 1. And down here, I'm going to say text block 2.text equals hello from observer 2. Okay, any bets on this last one? Message box.show hello from observer 3. So the idea behind this is I'm setting up 3 subscribers, 3 observers. And these are now observing the state of the click, actually I guess they're observing the click state of our button. So hopefully you guys can figure out what this application's about to do, but I'll go ahead and run it and click the button anyway. So when I click the button, all 3 of my subscribers are notified. Are you guys not impressed with my programming skills? But see, that's the point. It's not difficult. All I've done is put a name to something that we do all the time. Now, when we're talking about the observer pattern, again, this is just one way to implement it. And we have a built-in implementation in our programming environment, which makes it really easy. And what that means is that if I have a problem and it says, well, you know what? I need to set up this publish-subscribe relationship. I need someone to get notified when the state changes. Well, the first thing I can do is say, hey, you know what? That's the observer pattern. And you know what? Event handlers implement that. Can I use that? And you might look at it and say, well, no, that's not quite appropriate in my environment. Well, there's other pre-made implementations out there. In the Prism framework, there's an event aggregator, which is a really cool little object. And in that situation, the publishers and subscribers don't even have to know about each other. They just have to know about this central event aggregator. That's pretty cool. And starting with .NET 4.0, we even got these interfaces in the framework, iObservable of T and iObserver of T. And those are interfaces that just kind of describe the functionality that then we can implement however we want to. So again, there isn't just one way to implement the observer pattern. There's a million different ways of doing it. Now, should we reinvent the wheel? No. Again, let's go ahead and stand on the shoulders of those really smart people that have done this before us. So let's look at the tools that are out there. And again, if they don't fit, it's okay to go ahead and do something different. You guys got the observer pattern? How difficult was that? Was that difficult? I hope not. Because it doesn't get much easier than that, right? Hooking up an event handler to a button. So, actually, before I move on, let me talk about some consequences. I talked about there being consequences to our patterns, and the observer pattern is exactly the same. It has consequences. So another example that I will use is a stock ticker application. Okay, so there's a little application. It's listening for updates from the stock exchange. Every time it gets an update, it updates its UI, makes a record, does whatever it needs to do. But here's the thing. From the standpoint of the observer, they have very little control over this relationship because they don't know how many times they're going to be notified. They might be notified once. They might be notified a bazillion times. They don't know how frequently they're going to be notified. As you can imagine, if I hook up a real-time stock ticker, maybe I'm getting 10 updates a second. I don't know. Delayed by 15 minutes, of course, because they always do that. And the other thing is, I don't know if I will ever get notified at all. So those are things that we keep in mind. So if it's important that I have that first item come up, well, maybe I need to put a default record there because I don't know if I'll ever get that first notification. So again, does that stop us from using the pattern? No. But it might affect the way that we implement our particular solution. Okay, so let's move on to our next amazing pattern, which is the proxy pattern. And again, here's our awesome Gang of 4 description. Provide a surrogate or placeholder for another object to control access to it. Okay, Jeremy, can you give us a real-world example of that? Sure, I can do that. So in my real-world example, we're going to talk about power of attorney, because this is really fun. So my brother, for whatever reason, lives in Africa. And so he's off, 10,000 miles away from where I normally am. But, here I am back home. I don't actually snowboard, but I do play a snowboarder in video games. And in this situation, he's given me power of attorney. So that means I act as his proxy. Now, what does this mean from like a normal day-to-day standpoint? Well, it means that if there's somebody that needs my brother to sign a contract, they basically have 2 options. They can figure out how to fax it overseas, get the response back, get the signature and all of that, or they could interact with me as his proxy, and from a legal standpoint, that is exactly as legally binding as if they were interacting with my brother directly. So they have that choice. When I'm acting as his proxy, hey, come talk to me. It's just like talking to my brother. Now, I haven't abused my power, so, unfortunately, he does still own his house. I don't own his house. But, those are the kinds of things that we can get with a proxy. Now, in our programming world, proxies become really useful when we're talking about SOAP services. Why? Because SOAP services are self-describing services. And what that means is that our IDEs can generate a proxy class for us that makes it really easy for us to use those services. So let's take a look at that. Now, before I show you the code, let me go ahead and just show you this amazing application, because I know I'm going to have you guys just so enamored with my UI skills by the time we're done today. So now we've got a button and a list box. So we're stepping up in the world here. Now what I have is I have a WCF SOAP service that's actually here in another project that we can take a look at. And this is where we want to get our data from in this case. So this is a pretty simple service. So it just has one method, which is called getPeople, and it returns a list of person objects. And if we look at what a person is, we'll just peek into that definition. We see it's a very simple object. It just has a first name, a last name, a start date, and a rating. That is the shape of our data. And then if we were to look into this method, all we would see is its hard-coded values. So we're not even going to a database or a text file or anything. It's just creating a hard-coded list of person objects. So let's think about how we use this. So for this, I'm going to go back to my WPF application, and we'll take a look at the code behind for our form. And how do we do this? Well, what we do is we come in and we right-click and we say, add service reference. Woo. We tell it where to find stuff. In Visual Studio, I can say discover, and it'll just find everything that's in this particular solution. And then it will generate a proxy class for us. And in fact, I've already done that earlier, so I won't do it again. So let me go ahead and just instantiate that. So var proxy equals new person service client, which is the name of the proxy class that Visual Studio generated for me. And then I can say, I can call proxy.getPeople, right? So that's the method that we just looked at. And that'll give me back a collection of person objects. And after that, I can go ahead and iterate through that. So I love for each, so I use for each wherever I can, or for ac. So for each person in people, person listbox.items.add person. That's pretty simple code, right? You've probably seen code like that. And when we run our application and click our button, we'll see, ta-da, now we have data. Now, I know you guys are really kind of unimpressed by that because this is kind of something we see all the time. But have you ever thought about what's actually going on behind the scenes here? Because that SOAP service is theoretically on the other side of a network. Now, in this case, it's a network running on my same machine. But in order to talk to that service, I need to generate an HTTP request. And that request needs to have a SOAP envelope in it. That SOAP envelope is this big mess of XML. So if I want to communicate with this service directly, I need to create this big ball of XML, put it in a SOAP envelope, send it across HTTP, wait for a response to come back, which is also a big ball of XML, pick all of the pieces out that I think are useful to me, and put them into a C# object that I can actually use in my code. Or I can use a proxy. So again, this is actually what's going on behind the scenes. Now, when I talk about a proxy and say interacting with the proxy is the same as interacting with the class directly, let's just take a closer look at that. So if we go back to our service and look at this class, we have a class called person service. It has a method called getPeople. Now, assuming this wasn't a service and I just wanted to use this class in code, what would I do? Well, I would say, create a variable equals new person service, and then I would say person service.getPeople. Right? That's how I do it directly. How do I interact with my proxy? Exactly that same way. So I say new person service client, which is our proxy, and then I call proxy.getPeople. I don't have to worry about all that HTTP mess. I don't have to worry about all that XML. That's handled for us by this infrastructure. So again, this acts as a stand-in that really makes it easier for us to interact with something that's across the wire in this case. And we can interact with that object across the wire exactly the same way as if it were local. I think that's pretty cool. You probably never thought about what goes into one of these calls. And then if you're ever curious, you can always click into this. So if I right-click on the getPeople method, this will, and say go to definition, this takes us into the proxy object that Visual Studio generated for me when I said, import service reference. And we can see it says base.channel.getPeople, and this is what's responsible for creating the big ball of XML and handling the response and everything. So again, it's really cool to have this stuff out there so that we don't have to worry about it. Now it turns out that the proxy class has kind of an interesting history, because in the Gang of Four book, they actually describe a different use for this. Now, what they described is they said, oh, okay, well, it's 1994, and our networks are kind of slow. And if any of you were alive in 1994, you would know our networks were kind of slow. So if I have an application, rather than bringing an image across the wire, maybe what I'm going to do is put a placeholder image on our application, and then if you decide, hey, you know what, I really want that full image, then we can click on the placeholder, and it will go ahead and go through that intensive process of bringing down the real image, for like 20 minutes, right? Anybody remember that? I won't make you raise your hands because you probably got arthritis, right? So this was what they described in the Gang of Four book, and when I first read that, I'm like, boy, that's like no longer relevant. But then I'm like, you know what? We run into the same problem on our phones. I mean, we like to think, oh yeah, I've got LTE everywhere. Well, you guys should drive home with me tonight, going down the 5, and stop at the Button Willow rest area. And when you look at your phone and it says 2G, you're kind of like, come on, you can do it. So we do still have situations with constrained networks, and unfortunately, Twitter doesn't deal with this. I wish they did. So even though it sounds like an archaic problem, we still have that today, just in a different environment. So again, we have these same problems that occur over and over and over again in our environment. You with me so far? Let's look at another pattern that we're already using, the chain of responsibility pattern. I love this one. Avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle that request. Chain the receiving objects and pass the request along the chain until an object handles it. That's a big ball of text right there. Well, for a real-world example of this, we're going to look at the lovely world of tech support. Everyone's favorite phone number, right? So what happens when you call tech support? Okay, so my DSL modem goes down. Well, I call up the number, and I probably end up talking to somebody who doesn't even have a computer in front of them. They just have a list of questions to read, right? Have you tried turning it off and on again? Now, I have to imagine that works a lot of the times, otherwise they wouldn't pay the person to do that. Now, that sounds like something you can automate. In fact, AT&T has, because I had to call when my DSL modem was out last week, and the computer asked me if I tried turning it off and on again before I even got to a person. They're like, before we let you talk to a real person, can you try a couple things for us? It's like, okay. Now here's the thing. If that solves your problem, the message stops, and everybody's happy because your internet is working again. Now, if they can't solve the problem, then what that person does is they pass it to the next person in the chain. And in this case, hopefully it's someone sitting in front of the computer, and they're probably there saying, okay, well, let me see if our central office can connect to your modem, see if there's a problem in between. And again, if this person can solve your problem, beautiful. We're done. Message stops, we're complete. Now, if they can't solve the issue, then they pass it to the next member in the chain. And in this case, it might be a person in a truck driving out to your house to check the wiring. So this is how the chain of responsibility works. We have the first object gets a chance to handle the message. If they can, great, we stop. If not, they just pass it to the next member of the chain. If they can handle it, great, it stops. Otherwise, they pass it to the next member of the chain. That's all it is. Okay, I have a question for you, and I'm always afraid to ask this question. Who here has ever used a try-catch block? Now, the reason that makes me scared is I see all the hands that don't go up. And it's like, ah. Well, it turns out that exception handling implements the chain of responsibility. Now, you might be saying, huh, really? Sure. Okay, now you guys are going to be really impressed with this application. Now, I would highly recommend you do not write this application yourself. Let's go ahead and close all files here. And we'll move on to our chain of responsibility. Let me go ahead and just set this as our startup project. And then let me just run the application before I show it to you. I'm going to start it without debugging. Now, this is an application we've graduated to a drop-down box. And in here, I have a list of 4 exceptions that we can pick from. And when you click the button, it throws that exception. Now, I would really recommend not writing an application like this yourself. Now, granted, I have some users who treat my applications as if this is what they do. Without fail, it's like, Jeremy, I got an exception. Like, what did you do? Well, I just clicked this button. Really? So I don't have any exception handling in this. So, of course, what happens when we click the button, it throws an exception, and then we get this lovely dialog that says, uh-oh. And then we get the great debug and close program. Now, do you remember what we had in Windows 7? There was a third button on that screen. Do you remember that button? Check for a solution on the internet. Do you remember that? Did it ever do anything? No. Well, it turns out I had a buddy tell me, did you know there's a spot in your application that you can put a URL in, and that gets hooked up to that button if there's an unhandled exception? I'm like, oh. Nobody used it. Yeah, that's why it's gone now. But obviously, this is not a good experience for our user. Of course, I would probably argue that this entire application is not a good experience for the user. But let's go ahead and take a look at what this is. Now, I have kind of done a little bit of making this arbitrary so that we can kind of see the chain of responsibility. Because here, in my click me button click method, I have a call to method 1. Now, method 1 has a call to method 2. And method 2 is where we actually check to see what's in our combo box, and it throws the appropriate exception. Now, the reason I did this is so that we can watch how the exception handling process walks the call stack. And I'm going to do that by putting in some try-catch blocks. Okay, I love keyboard shortcuts. So what I'm going to do is I'm going to highlight this entire block of text. I'm going to use the keyboard shortcut Control-K, Control-S, which stands for surround with. And then you'll see it pops up my snippets. And I type in try because I want to try catch block. And it automatically wraps my highlighted text in a try block, adds a catch block, puts my cursor on the exception so I can change it. This is something lazy programmers really love. I love this. Okay, so let's go ahead and catch an access violation exception here. And for this, there's a text block, and we'll set its text to caught in method 2. That's where we are. And we won't rethrow it because, again, we're handling the message, so it stops. Now, let's go ahead and go up to method 2. I'm going to do the same thing. So, Control-KS, try, and we'll give this guy, he wants that second one, which is a null reference exception. And we'll set our text block. Caught in method 1. And again, we will not rethrow this. And the last one is an argument exception, which I will forget about immediately. So Control-KS, try, argument exception. Does that sound right? And then we'll just set our text block to caught in click. Okay, right? Pretty simple. You guys with me? Let's go ahead and build our application. And again, I'll go ahead and start this without debugging so we don't get hung up in the debugger. Okay, so what happens if I say I want an access violation exception? Well, we see it says caught in method 2. And the reason for that is the exception gets thrown here, and then in our catch, it looks at the message and it says, are you an access violation exception? Great, I know what to do with you. And then everything stops. Now, if we go ahead and throw a null reference exception, now it says caught in method 1. Now the reason for that is, again, it goes through this try block, hits this catch exception, says, are you an access violation exception? Nope. Okay, go to the next member in the chain. Now in the case of exceptions, that means I'm going to walk up the call stack. So if we walk up the call stack, we do get to method 1, and it says, are you a null reference exception? Yes, great. Fine, I'm going to handle you. Message stops. And you're kind of getting the idea, right? So the same thing happens if we choose the argument exception. It'll say caught and click, because again, method 2, it'll say, are you an access violation exception? Nope, go to the next member of the chain. In method 1, it'll say, hey, are you a null reference exception? Nope, go to the next member of the chain. And then the click event says, hey, are you an argument exception? Great, I know what to do with you. See, so it really isn't that hard. Now, normally we don't have these call stacks all in one particular class, but again, it gives you an idea of how this works. Now, I talked about consequences. There is a consequence to the chain of responsibility. What happens if nobody is prepared to handle that message? What happens if I just throw a plain old exception? Well, in this case, we're back to where we started. So we have an unhandled exception. So basically what happens with the chain of responsibility is if that last member of the chain can't handle the message, it just falls off the end of the chain. And that's something we need to be aware of. Now, in this world where we're dealing with exception handlers, we normally put in a global exception handler, right? So that's a spot in our application that no exception can get past. And that way we can give a good experience to our users. And hopefully we're logging the information so we can put a more appropriate exception handler somewhere else in our code. Now, unfortunately, this does have the same problem in our real-world implementation, because if the person in the truck comes out to fix your wires and they can't do anything for you, you might be out of luck. So it's something that actually happens in our real-world implementation as well. So do you guys kind of feel like design patterns aren't that big of a deal? Do you want to look at some more? Okay, good. Otherwise, I was going to let you guys go home. Fine, I'll show more. Okay, so let's head on to the iterator pattern. The iterator is actually one of my favorite things in the .NET world. So here's our Gang of 4 description. Provide a way to access elements of an aggregate object sequentially without exposing the underlying representation. Now, our real-world implementation of this will be our TV remote control. And we're probably really all familiar with the TV remote control, right? It's got that cool channel up button, right? And all we're saying is, give me the next item, give me the next item, give me the next item, give me the next item. And we don't care about the underlying implementation. You know, our TV is probably skipping the channels that have no signal on them. And you know, if your garage is full of stuff and your credit cards are maxed out, it's also probably skipping the home shopping channels because you know how dangerous those are. And again, we don't care about the underlying representation. We just say next, 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 next. And that's all the iterator pattern is. So, has anyone here used a for each loop? I love for each loops. For each loops are awesome. For each, what?
There almost could be a for each pattern by your logic, yeah?
Okay, so the comment is there could be a for each pattern by my logic. Well, technically, I would say for each falls under the iterator pattern because it actually does this next, next, next that we're talking about. So let's go back to our code and take a look at this. And we'll look at our iterator. And you guys have already seen this UI. We're back to our button in our list box. So, you know, sorry, I'm doing some repeats here. And in this case, I'm not accessing a separate service. I just have a person class that's part of this same project. So it just has, it's a people class that has a getPeople method, and then the person object is embedded in the same file. So let's go ahead and use this. So I'm going to say var people equals people.getPeople. Now, if we look at what's coming back from this, this is a list of T. Now, I love generic lists. So I could say list of person to be a little more explicit. But when we're talking about iterators, what we call them in the .NET world is enumerators. So rather than accessing the list here, I'm going to use the interface that represents an iterator, and that is IEnumerable. So anything that implements the IEnumerable interface, I'm allowed to for each over. So I can say for each var person in people, person list box.items.add person, just like that. Pretty cool, huh? And run the application. You guys are waiting for the surprise, aren't you? Sorry, there's no surprises. This isn't difficult stuff. Now, what I really like about IEnumerable is that's what makes LINQ so awesome, because LINQ works on IEnumerable, and I love LINQ. And Lambda expressions are kind of a side effect of that, too. So when we look at IEnumerable, anything that implements the IEnumerable interface, we're allowed to use for each on. And so pretty much every collection in the .NET framework implements IEnumerable, which means we can iterate over it. And there's some things we might not expect. Did you know that string actually implements the IEnumerable interface? It's an IEnumerable of char. So you can actually for each over a string and get all the characters out. And I have had a good reason to do that, surprisingly enough. So this is one of those things that I really love. But again, all it is it's saying next, 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 next. And it's built into our language. Now, what's interesting is if you look at the Gang of 4 book, in one of the appendices, they actually implement a list class that has an iterator built into it. Because again, it was 1994 and you had to do that kind of thing back then. Now, fortunately for us, we're living in 2015. And we have these frameworks and libraries and languages that have all of this cool built-in stuff for us. And again, if it works for us, let's go ahead and use it. So if I just need a collection of something that I can iterate through, well, maybe I'll use a list because the generic list is built into .NET. But if I find out, you know what, that default implementation isn't really doing it for my particular problem, well, maybe I take that IEnumerable interface, implement it on my own custom class that has exactly the code that I need. So again, there's not just one way of using these patterns, and that's what makes them so awesome and powerful. We're talking about concepts. There's a lot of great implementations that we should look at first, but if they don't fit our environment, we don't have to feel bad about creating our own. Okay, I've got one more pattern to show you. It's an awesome one. Well, these are all awesome, aren't they? They're simple. We use them all the time. Well, this last one is the facade pattern. Facade pattern. And the Gang of 4 book doesn't have the little curly thing under the C, but whenever you type it into PowerPoint, it puts the little curly thing under the C. So I don't know which the technical correct spelling is. I spelled it the Gang of 4 way. So here's our definition. Provide a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use. These definitions aren't very useful, are they? Well, let me show you a real-world example of the facade pattern. And that is Jeremy's home entertainment system. So in my house, I have 3 different remote controls. I've got one for the DVD player, one for the television, and one for the stereo. So if I want to go in and play a DVD, then what I do is I turn on the TV if it's not already on. Then I set the TV to the component input. Then I turn on the stereo if it's not already on. Then I set the stereo to the aux input. And then I turn on the DVD player if it's not already on. And I press play. Now, as a couch potato, I can do this without even looking at the remote controls. So this complex subsystem isn't really a big deal when it's me. But I have a friend who's nice enough to come in and check on my cats when I'm traveling. And for whatever reason, she likes to watch Gunsmoke with the cats. I don't know why she does. But the thing is, this is kind of complicated for someone who just wants to watch Gunsmoke with the cats and they're not used to these buttons all the time. So a better implementation would be to have a universal remote control, maybe one of these cool Logitech ones with a touchscreen on them. And then I just press the watch a DVD button in this case. And it will figure out the complex subsystem, figure out what needs to be turned on, what needs to be set to what input, et cetera. And so what this is doing, it's wrapping that complex subsystem in something that's really easy to use. And so that's all our Facade is. Although Facade makes you sound kind of smart when you say it, right? I like to use design patterns in everyday talk just because it makes me sound like I'm really important, right? So, I use dependency injection on a regular basis. How about you? Constructor injection, that's really awesome. Anyone know constructor injection from yesterday? Yeah, you guys know it's just a parameter, right? So, let's take a look at a programming example of using the Facade pattern that we might use on a regular basis. Okay, so here's a question for you. Let me just set this as our startup project. Who here has used a for each loop? It's a different set of people than the ones I asked last time. It's a little disconcerting. Well, it turns out that the for each syntax is actually a facade around the methods that we get with IEnumerable. Let me show you what I mean by that. And for that, okay, again, let me show you this awesome application, which looks exactly like the last awesome application that we did. And let me pop this open. And you can see we've already got our IEnumerable of person here. And again, normally what we do is we say for each var person in people, person listbox.items.add person, right? Just like that. This code should look familiar because we saw it about 5 minutes ago. Again, that's how we can get data in. But this is just an easier syntax over using this IEnumerable object directly. So to kind of look at what we have on IEnumerable, I'm going to say people dot. And you can see we've only got 5 items on here. And 4 of them come from object. So the IEnumerable interface actually only has one unique method, and that's the getEnumerator method. And what this does is it returns an IEnumerator of person. Okay, so let's call getEnumerator like that, and we'll say var enumerator equals people.getEnumerator. And again, if we look at this, we see that this is an IEnumerable of t, where t is a person. Now, if we look at the enumerator object and say dot, what we'll see is we've got quite a few things here. Now, we have a property called current. This represents the current item that we're on. Then if we move down a little bit, we'll see we have a move next. Now, move next, that's my next, 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 next. So we call move next the method in order to go to the next item that's in our iteration. There's also a reset. And then something that's important to note is that second item up there, dispose. So this actually implements iDisposable, which means if we want to use this object in a way that David McCarter won't get mad at us about, and go to any of David's talks today, then I really should put this in a using statement. If I can type that. Using var blah, blah, blah. And so when we use a using statement on something that implements the iDisposable interface, then once we exit this block, it automatically calls the dispose method so we don't have to do it manually. And that's something you should do on all of your disposable objects. Now inside here, I want to use that move next. So I'm going to say enumerator dot move next. And if we look at this method, what we'll see is it doesn't return the next object. It returns a Boolean, a true-false value. So what it does is it tells us whether that move next was successful. Well, that sounds like a candidate for a while loop to me. So we can say while next, 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 next. And then what do we use? Well, again, we have enumerator.current, which represents whatever item we're currently on. So I can take that and actually put it into our list box. So we'll say personListBox.items.add enumerator.current. And if we run our application, what we'll see is we get exactly the same results that we had before. So this is actually what the compiler does in the background. Now, if you're really nerdy, I'm really nerdy, then you probably like to look at ILDASM from time to time. And what that does is it cracks open the .NET assembly so that you can look at the IL, the intermediate language that's generated. What's interesting about for each is if I for each over this collection, or I do this manual enumeration, they both generate exactly the same IL. Why? Because for each is just a facade around this complex subsystem. It wraps that complexity so we don't have to look at it as programmers. That's what makes facades really cool. Now, there are consequences to the facade pattern as well. One of those is, since we're simplifying this process, a lot of times we'll lose visibility to some of the details underneath. And in this case, I mean, our IEnumerable is pretty straightforward to start with. But for example, I pointed out that there's a reset method on our enumerator. There's no way to call that method from a for each loop. Now, quite honestly, I've never used the reset method in any code that I've ever built. A lot of times we'll just say, oh, well, we'll just exit out of this for each loop and create another one or iterate over it again, right? So in real life, it's usually not a problem. And again, that's why we're willing to accept the consequences of the pattern. We get more benefit out of it than the drawbacks that are there. But we need to be aware that the drawbacks exist because it might alter our judgment on whether we should use the pattern, or we might want to add a little bit of additional code to make sure that we don't have problems with those consequences. Sound reasonable? So, in case you haven't figured it out, I really love design patterns. And what we've seen today is that they're not just for architects. We use these patterns all the time in our code just as day-to-day programmers. And we just see them over and over and over and over again. So we're going to go back and talk a little bit. Actually, let's hit our slides. There's actually a couple more in the extended version of this presentation that I don't have time to show you today, unfortunately, which is the factory method pattern and the decorator pattern. And they're both really cool. For those of you who were in my DI talk yesterday, you saw a little bit of the decorator pattern when we created that caching repository, which was really awesome. And again, you can go online and get some more information about those. But let's kind of loop back to what design patterns are and think about, are they still relevant in our world? Well, again, here's Christopher Alexander. Each pattern describes a problem which occurs over and over again in our environment. We have this notification issue come up over and over again. We have this complex subsystem issue come up over and over again. So these are nothing new. They're just things that exist in the programming world. So the patterns describe the core of the solution to the problem. Now, I was showing specific implementations today, but as you notice, I emphasized that there's other ways of doing this. Now, the reason I emphasize that is because when we are looking at pattern catalogs or descriptions of patterns, they usually have a reference implementation, some example, so that we as programmers can grab onto this and get a good understanding of what it is. But we really need to keep in mind, this is not the only way of implementing this pattern. In fact, if we wanted, we could use the pattern a million times over and never do it the same way twice. Now, I would highly recommend against that, because that sounds like an awful lot of code. So we should actually be building on the objects that exist in our framework. Again, at the time the Gang of Four wrote this book back in 1994, we didn't have these extensive libraries that we have today. And so a lot of times they were just hand coding all of this stuff. Oh, I need an implementation of an iterator. I need an implementation of our facade or our chain of responsibility. But now that we have these more robust libraries, we have a lot of options available to us without having to go in and build everything from scratch. Now you might say, does that mean these patterns are no longer relevant? Well, no, it's exactly the opposite, actually, because we do have these same problems, and we need solutions to them. And the thing that's good about understanding the patterns is once we can put a name to something, now we can look at the already implemented solutions. So if I look at a problem and say, you know what? I need an observer here. I have a notification issue. I need to set up a publish-subscribe relationship. And once I can make that identification, now I can start looking at, okay, what implementations of the observer pattern already exist in my environment? And again, in our case, event handlers are there. If I can use an event handler, great, let's use it. But again, if that doesn't work, we can use the event aggregator. We get a little bit looser coupling there. Or I can implement it myself using the iObservable and iObserver interfaces. And in fact, I don't even need to use those interfaces. I can do it another way, right? So we're free to actually pick the solution that meets our particular needs. Why do we want to use them? Really smart people have thought about this. And they've thought about it way longer than I have, and they've come up with solutions. I want to steal other people's solutions as much as possible. Why? Because that work has already been done. That frees us up to work on new problems. So I want to use these well-described solutions. And of course, when we start talking in patterns, this gives us a shared vocabulary, a way we can communicate very concisely. So hopefully now, if I come up to you and I say, I'm using the observer pattern here, you know exactly what I'm talking about. Without me having to describe, oh, I've got a class that fires an event, I've got something else that's listening to that event. Because you know what? A lot of times, we're still in design mode. And the specific implementation isn't important when we're having that discussion with another developer. And again, if we are using these words in everyday speech, it does encourage other developers to look into them and say, hey, are these things really, really awesome? And of course, my answer would be, yes, they are. Now again, the Gang of Four patterns is not where, you don't want to start with the Gang of Four book. If you are new to design patterns, again, I highly recommend the Head First Design Patterns book. And if you go out to my website and follow the links for this presentation, you'll find these slides, and you'll also find some book reviews for the books that I mentioned today, and some other materials, including links to the PDF walkthrough, as well as my Pluralsight course. So there's a lot of information out there that you can go and get to dive in a little more deeply. And so with that, I think I'm done. Thank you. And as a reminder, I do have some contact cards up here, so feel free to grab them.